This video is brought to you by the Abbey Community Skills Society. Hello and welcome back. My name is Laszlo, I'm your instructor. In this video, we're going to be talking about what is a 2D game, what are pixels and coordinates, what are games made of, what is the 2D game cycle, and finally, why we need to know all this. So let's get started. What is a 2D game? So first of all, let's define 2D. 2D means that it's got only two planes. That means it's only got an X and Y system plane. Think of it as a flat piece of paper. It's not going to have any depth. Moving on. So a 2D game to me is a beautiful mathematical dance of images. What do I mean by that? Well, you've got this flat piece of paper and you've got a lot of images on it. For example, we've got coins, bad guys, you've got your character, maybe a bird, and maybe even some things like your platform, your house, and the sun. These are all images that you see. And what are they doing? Well, they're moving around. So for example, the bird can move left and right. The character can move in every direction. The bad guy is maybe moving towards you. But that's all they are doing. They are moving on the screen. So images that are moving. It's like a big dance. For every dance, you need some kind of sound and music. So the game is going to have sounds and music. And finally, for it to be considered a video game, it needs to be player controlled. If it's not player controlled, then you're just watching a cartoon. Moving on. What are pixels and coordinates? So let's talk about pixels first. Every computer screen and TV screen that you've ever seen, even your phone or your iPhone or tablets, they all consist of screens. And every screen is made up of many little tiny dots. And these are called pixels. So pixels are tiny little dots. Most TVs nowadays are considered 4K. 4K means that there's at least 3,840 dots running horizontally, and then 2,160 dots running vertically. So this is your width, and this is your height. And that's how many dots they're made of. To make this a bit more clear, I'm just going to draw a bunch of little dots on the screen here. Kind of imagine that this is what your screen is made of. It's just a bunch of little dots that fill up your screen. Smaller TVs and computer monitors, even your phones, they tend to be more along the lines of HD. HD means that they have 1920 pixels running vertically, in width, and then 1080 running in height. W stands for width, H stands for height. Don't think of them as vertical and horizontal. Moving on. So our game is going to be 400 pixels in width and 600 pixels in height. This is specifically for this game. You can have other dimensions for other games. And the reason I wanted to highlight our game's width and height is so that you can compare it to an actual screen. So screen would be the thing that fills up your whole view. And then the game is something that's inside the screen. Let's expand this out. So moving on to this picture on the right-hand side here. We know that the game has a height of 600 pixels and a width of 400. When we're talking about coordinates, we need to know how do these coordinates relate to the screen. So in the bottom left corner here, you see that I've highlighted a point and I called it 0, 0. That just means that if something was at that point on my screen, its coordinate or position would be accessed and it would tell us that its position is 0, 0. If there's something in the middle of the screen, its position would be 200. 200 is your X coordinate, which is your width. And since it's in the middle, it would be half of my width, which is 400 divided by 2, 200. And my height, which is represented by Y, would be half of 600, which is 300. And if I wanted to place something in the top right corner of my game, then its position would be at 400 pixels for X and 600 pixels for Y. Okay, this is just a very simple introduction for coordinates, pixels and coordinates. And the main reason is so that when we draw our images, we should know these dimensions and we should keep them in mind when we draw images, because you don't want to draw a very tiny image onto a big screen or a really big image onto a small screen. It wouldn't fit properly. Moving on, we've got the game building blocks. This is what makes a game. I like to kind of think of it as Legos, a Lego analogy. So we've already discussed that our game is going to have images and sounds. Those are what we experience as the player. But what makes all those images and sounds work? Well, you take the images and the sounds and you put them together, and not just images and sounds, you can also have scripts, images, sounds, and scripts, and you throw them together into collections, which would be your objects, or in Godot, they're called nodes. And then you take a bunch of these nodes and objects and you kind of put them together into a scene. And then, for example, a scene could be like your menu. An object itself could be a scene or a node. Levels are scenes or nodes, and then sub-scenes. And then once you've got all these scenes put together, you can build them into your game. So how is this? What's the Lego analogy? Where the Lego analogy is kind of like, before you can start building your Lego car or your Lego plane, you need the Lego blocks. Well, we don't have Lego blocks, so we have to build our Lego blocks first. Once we build our Lego blocks, we build, so these are our Lego blocks. Kind of think of these guys. So my images, my sounds, my scripts, these are my Lego blocks. I put them together and I start building things like objects. So for example, a door, and that's my object. Once I've got enough objects, I can start putting them together into bigger things. Like for example, I could put together like a fire truck or a fire hall or something like that. And that's where you're starting to move on to things like scenes and your rooms. And then finally, when you put all your Legos together, so maybe the fire truck with the fire hall and a park right outside, that's where you've got your game. Okay, so there's quite a few steps, and game design is really just wonderful because you have to go through all of these steps from the very beginning. Moving on, what is the game cycle? So this is one of the most important things to understand in game design, and this is true for both 3D and 2D games. Games consist of basically two stages. You've got this draw stage. So the draw stage represents the part where the computer is drawing graphics onto the screen. So that's what you actually see. But before it can draw graphics onto the screen, it has to decide where to draw them. Where do I draw the character? Where do I draw the coins? What image do I draw? Things like that. And that comes in the update, step, or process part of the cycle. I wrote all three because if you're working in Unity, you'd be using update. If you're working in GameMaker, it would be called a step. And if you're working in something like Godot, it's called a process. And during the second part of the cycle, everything from inputs, so that means like the player pressing some buttons, logic, for example, I press the left key, therefore my character should move left. Physics, I just hit a box, maybe I shouldn't move left because there's a box there. Collisions, I just hit a coin, that's a collision, should I pick it up? Triggers, maybe I stepped on a platform that needs to open a door now for me. Timers, maybe there's a timer counting down for, like, you have a power up and it's running out of time, and etc. So these are all things that would happen during this update, step, or process cycle. And then once the computer calculates these out for you, then it goes back and draws everything for you. What's crucial to understand is this is happening extremely fast. We're not thinking in terms of minutes or seconds. We are thinking in microseconds, or microseconds. One way to think of it is all of this is happening at 60 frames per second. So that means I'm going to be getting 60 pictures drawn on my screen every second, and I'm also going to be doing all these calculations and input tests and all these things 60 times a second. And that's not set in stone. Some games run at 30 frames per second, and some run at 200, 300, 400, 600, it doesn't matter. Ours is probably going to be running at something like 60 frames per second. The main thing to note about this is that when we start thinking about movement, for example, we do need to realize that all of our position changes are happening 60 times per second, which means that you might think that a small pixel change is not enough, but when it happens 60 times a second, it's actually a big shift on the screen. Moving on. So why know all this? Well, if you don't know anything about how games work, we have no idea where to start. Because we know how games kind of work now, it will guide our next steps. So that's why we want to know it. It also kind of tells us what do we need to do. So also this kind of relates to our next step. So knowing how the game works, we know what we need to do next. It also shifts our thinking and problem solving approach because especially with the timing, we need to understand how fast things are happening to kind of pull our thinking into like this microscopic state. And then it is foundational, so not knowing any of this would make game design almost impossible. And yeah, so we need to know all these things. And I highly recommend that you maybe even rewatch this video a couple of times just to really get a grasp of what is a video game in its core. And finally, what's next? So moving on, we will be installing some software. As I said, the software we're installing is Audacity, Godot, and Krita. And then we are going to move on to planning our game. And then once that is done, we can actually jump into building our game. Thank you for watching, and see you in the next video.